Right now, as you listen to these words, something strange may be happening. The past might still exist. The future might already be real. And this moment, the present, the thing you feel slipping away second by second, may not exist at all. We experience time as a steady flow, one moment replacing the next, a clean line from yesterday to today to tomorrow. It feels obvious, natural, undeniable. But physics tells a very different story. According to modern science, there is no universal now, no single present moment shared by the universe, no cosmic clock ticking forward for everyone. Instead, time behaves in ways that directly contradict human experience. Clocks slow down. Moments stretch and compress. Events that appear simultaneous to one observer are not simultaneous to another. And under certain conditions, time can nearly stop. This is not science fiction. This is not philosophy. This is established physics, tested, measured, and confirmed. Which raises a deeply unsettling question. If time does not behave the way we experience it, then what exactly are we experiencing? Consider this. Two people can disagree about whether events happened at the same time, and both can be correct. Not metaphorically, literally. In some reference frames, an event in your future may already exist. In others, it has not happened yet. So which one is real? Is the future fixed? Is the past still there? Or is reality far stranger than we have ever imagined? For centuries, time was assumed to be absolute, a universal backdrop against which the universe unfolds. Seconds tick, hours pass, cause comes before effect. That assumption felt so natural that it went unquestioned, until it broke. At the beginning of the 20th century, a single realization shattered everything humanity believed about time. A realization so profound that even today, many physicists admit they do not fully understand its implications. The universe does not agree on what now means. And if that's true, then the idea of time flowing forward, the idea that the present is special, may be nothing more than a psychological illusion. Think about that. Your entire life is organized around something that may not exist. Your memories, your plans, your sense of aging, your fear of death, all depend on time being real in the way it feels. But what if time is not moving at all? What if every moment, past, present, and future, already exists, laid out like pages in a book? What if you are not traveling through time, but simply experiencing one page at a time? This idea sounds impossible, yet it emerges naturally from the same equations that power GPS satellites, nuclear reactions, and modern cosmology. And once you truly understand it, you can never see reality the same way again. Because if time is an illusion, then the past is not gone, the future is not waiting, and death may not mean what we think it means. Today we are going to follow the evidence, slowly, carefully, from human intuition to experimental physics to the deepest theories of reality. We will see how time breaks, why it breaks, and what that means for consciousness, free will, and the fate of the universe itself. Prepare yourself, because once you see what physics has discovered about time, there is no going back. For most of human history, time felt simple. The sun rose, the sun set. Days passed, seasons changed, lives moved forward. No matter where you were or who you were, time seemed to flow the same way for everyone. A second here was a second everywhere. The present moment felt universal, shared by the entire world. This belief was so deeply embedded that even the greatest scientists accepted it without question. Isaac Newton, whose laws shaped physics for over 2 centuries, described time as absolute.
To him, time flowed evenly, independently of anything happening in the universe. Space could bend, objects could move, but time itself was fixed and eternal. It was the stage on which reality played out. And for a long time, nothing seemed to challenge that idea. Until a problem appeared. By the late 1800s, physicists noticed something strange about light. No matter how fast an observer moved, light always traveled at the same speed, approximately 300,000 kilometers per second. This made no sense. If you run toward a beam of light, you would expect it to appear slower. If you run away, faster. That's how velocities work in everyday life. But experiments showed that light ignored these rules. It behaved as if the universe enforced a strict speed limit, one that could not be exceeded and could not be altered by motion. This contradiction shook physics to its core. And in 1905, a young patent clerk named Einstein proposed a solution that would quietly destroy the concept of time itself. Einstein suggested something radical. What if the speed of light is constant for everyone, and it is time that changes instead? At first, the idea sounded absurd. Time changing based on motion? Clocks ticking at different rates? The present moment not being shared? But when Einstein followed the logic, the mathematics worked perfectly, and the consequences were unavoidable. According to Einstein's theory of special relativity, time does not pass at the same rate for all observers. The faster you move through space, the slower you move through time. This effect is not a trick of perception, it is real. If two identical clocks are synchronized and one is placed on a fast-moving spacecraft while the other remains on Earth, the clock in motion will tick slower. When the spacecraft returns, the clocks will no longer agree. The moving clock will show less time has passed. This has been measured repeatedly. Atomic clocks placed on airplanes run slower than those on the ground. Satellites orbiting Earth must constantly correct for time dilation, or GPS systems would drift by kilometers each day. Time is not universal. It is personal. But here is where things become truly unsettling. Time dilation alone is not the real problem. The real problem is simultaneity. Einstein showed that two events that appear to happen at the same time for one observer may not happen at the same time for another observer moving at a different speed. There is no universal now. Imagine two lightning strikes hitting opposite ends of a moving train. An observer standing on the platform may see them occur simultaneously, but an observer inside the train, moving toward one strike and away from the other, will see one strike occur before the other. Both observers are correct. There is no universal answer. This means the present moment depends on your motion through space. Let that sink in. If there is no universal present, then the idea of time flowing forward together for the entire universe collapses. Past, present, and future lose their objective meaning. And this leads to a disturbing conclusion that Einstein himself struggled with. The universe does not evolve moment by moment. Instead, all moments exist. Physicists call this the block universe. In this view, time is like a dimension of space. Just as all locations exist at once, all moments exist at once. Yesterday, today, and tomorrow are equally real. Nothing is coming into existence. Nothing is disappearing. Reality simply is. We experience time as a flow, not because it actually flows, but because our consciousness moves through it. This idea explains relativity perfectly. It also destroys our intuitive understanding of reality. If the future already exists, then what does that mean for choice? If the past still exists, what does that mean for loss? If the present is not special, then what does that mean for life itself? Einstein once wrote near the end of his life that the distinction between past, present, and future is only a stubbornly persistent illusion. Not a comforting illusion, a stubborn one. And once physics revealed it, there was no way to unsee it. Time was broken. But this was only the beginning, because when scientists pushed deeper into gravity, black holes, and the origin of the universe, time didn't just bend, it began to disappear entirely.
Einstein's first revelation showed that motion can change time. But motion is only half the story. Because a decade later, Einstein uncovered something even more unsettling. Gravity also changes time. Before this discovery, gravity was thought of as a force, something that pulls objects together. Apples fall, planets orbit, stars form. But Einstein reimagined gravity entirely. He proposed that gravity is not a force at all. It is a distortion of space and time themselves. Mass bends space, and that bending affects time. The stronger the gravity, the slower time passes. This is not a metaphor. It is measurable reality. A clock placed closer to a massive object will tick more slowly than a clock farther away. Even on Earth, this effect exists. Clocks at sea level tick more slowly than clocks on mountaintops because gravity is slightly stronger closer to Earth's center. The difference is tiny, billionths of a second, but it is real. And once again, GPS satellites must correct for this effect to function properly. Without accounting for gravitational time dilation, your phone's location would drift by several kilometers every day. Time is already breaking, right here, right now. But Earth's gravity is weak compared to the monsters scattered throughout the universe. Neutron stars, black holes, objects so dense that they warp reality to extremes. Consider a neutron star. It is the collapsed core of a massive star, packing more mass than the sun into a sphere roughly the size of a city. A teaspoon of its material would weigh billions of tons. Near a neutron star, time slows dramatically. A person standing on its surface, if that were possible, would age far more slowly than someone far away. Minutes for them could equal hours elsewhere. But black holes push this effect to its absolute limit. A black hole forms when a massive star collapses so completely that space-time curves inward without limit. At its boundary, the event horizon, gravity becomes so intense that not even light can escape, and time behaves in a way that defies intuition. To a distant observer, an object falling toward a black hole never actually crosses the event horizon. Instead, it appears to slow down, freeze, and fade away. Time, from the outside, stops. For the falling object itself, however, time continues normally, at least for a while. Two realities, two timelines, both correct. This means that time does not simply slow down near black holes, it fractures. There is no single story of what happens. The universe allows multiple, equally valid descriptions of reality, depending on perspective. And this creates a problem, because if time behaves differently in different regions of the universe, then time cannot be fundamental. It cannot be the underlying fabric of reality. Something more basic must exist beneath it. This suspicion grows stronger when we look backward, not toward black holes, but toward the beginning of everything, the Big Bang. When cosmologists trace the universe back to its origin, they encounter a strange boundary. As density and temperature rise toward infinity, the equations break down. Space becomes undefined, and time loses meaning. At the Big Bang, time does not simply begin. It ceases to behave like time at all. There is no before the Big Bang in classical physics, because before requires time, and time itself emerges from the universe. This leads to a deeply unsettling conclusion. Time may not be fundamental. It may be a byproduct, an emergent phenomenon arising from deeper laws that do not contain time at all. Some theories of quantum gravity suggest exactly this. In their equations, time is absent. There is no ticking clock, no flow, only relationships. Change without time.
If this is true, then time is something the universe invents, not something it runs on. And if time is invented, then our experience of its passage may be a construction of the mind, a cognitive interface, a way for consciousness to navigate a static reality. This idea is difficult to accept because it implies that the universe does not evolve. It simply exists, every moment, all at once. And we are embedded within it, experiencing one slice at a time. But if that's true, if time is not fundamental, then the question changes. We no longer ask, what is time? We ask something far more disturbing. Why do we experience it at all? If time may not be fundamental, if physics allows every moment to exist at once, then why does time feel so real? Why does it feel like it moves? Why does the past feel fixed, the future uncertain, and the present fleeting? To answer this, scientists stopped looking outward toward space and cosmology and began looking inward toward the human mind. Because whatever time truly is, our experience of it is deeply tied to memory. We remember the past. We do not remember the future. That asymmetry shapes everything, every decision, every fear, every sense of cause and effect. But memory alone is not enough to explain the arrow of time. Something else gives time its direction. Entropy. Entropy is a measure of disorder. In simple terms, it describes how systems tend to move from order to chaos. Ice melts, smoke spreads, eggs break. But broken eggs never unbreak themselves. This one-way behavior defines the arrow of time, not because time itself flows forward, but because entropy increases. Physics allows most processes to run equally well forward or backward in time. The equations don't care which direction time points, but entropy does. Low entropy states are rare, high entropy states are common, and systems naturally drift toward what is statistically more likely. The early universe was in an extremely low entropy state, highly ordered, tightly constrained. As the universe expanded, entropy increased, and with it, the sensation of time moving forward emerged. In this view, time's arrow is not built into reality. It is built into probability. Your brain operates the same way. Neurons store information by creating physical changes, changes that increase entropy. Memory formation is a thermodynamic process. It leaves traces of the past, but not the future. You experience time moving forward because your brain is constantly recording what has already happened. The present feels special because it is the moment where information is being written. The future feels open because no information about it yet exists. And the past feels fixed because it is already encoded. But here's the unsettling part. This explanation does not require time to flow. It only requires change, a sequence of states ordered by entropy. From this perspective, consciousness does not ride time like a river. It navigates a landscape. Each moment is a configuration of the universe. Your awareness simply transitions between them. This means the feeling of motion, the feeling of now becoming then, may be a mental construction, a user interface, useful for survival, not a reflection of reality's structure. Some physicists compare this to how we perceive color. Color does not exist as a property of light itself, only wavelengths do. Color exists in the brain. Time, they argue, may be similar. There is no flow in the universe, only correlations between states, and consciousness stitches those correlations into a story. But this raises a disturbing implication. If time's flow is subjective, then the future may be just as real as the past, and our sense of choice, of becoming, may be far more constrained than we believe. Yet even within a block universe, meaning does not vanish. Experiences still matter. Suffering still hurts. Joy still matters. The story still unfolds from the inside. The illusion of time may be necessary, not to deceive us, but to allow experience to exist at all. Still, the deeper scientists push into physics, the more they encounter places where time behaves strangely or not at all. And nowhere is this more evident in the smallest scales of reality, where quantum mechanics rules and where time begins to dissolve completely.
At everyday scales, time feels reliable. Causes come before effects. Actions lead to consequences. The past influences the present. But when scientists began studying reality at its smallest scales, the realm of atoms and particles, this order began to unravel. Quantum mechanics does not treat time the way classical physics does. In some experiments, particles appear to influence events in the past. In others, outcomes are not determined until they are observed. These are not metaphors, they are measurable effects. One of the most disturbing examples is the delayed choice experiment. In this setup, scientists send a particle, like a photon, through an apparatus that can test whether it behaves like a wave or a particle. The twist is that the choice of how to measure the photon is made after it has already entered the system. And yet, the photon behaves as if it knew how it would be measured. If measured as a wave, it acts like a wave. If measured as a particle, it acts like a particle, even when the decision is delayed. This seems to violate causality. How can a future measurement affect a past behavior? Quantum mechanics offers no clear answer. It simply works. Another example involves quantum entanglement. When two particles become entangled, their properties become linked regardless of distance. Measure one and the other responds instantly, even if separated by light years. Einstein called this spooky action at a distance. But the deeper problem is temporal. The order of measurement does not always matter. In some reference frames, one particle is measured first. In others, the second is measured first. Yet the correlations remain. There is no definite before or after. At the quantum level, time ordering becomes ambiguous. Some physicists suggest that causality itself may be emergent, not fundamental, just like time. In certain interpretations of quantum mechanics, particles do not have definite properties until they are observed. Reality does not settle into a single history until measurement occurs. This raises a deeply unsettling idea. The past may not be fully determined until the present, and the present may not be fully determined until observation. Even some experiments suggest that quantum systems can exist in superpositions of different histories, multiple pasts, all equally real, until something forces a choice. This challenges everything we assume about time. If the past is not fixed, if the future can influence the present, then the idea of time as a linear sequence collapses. Physicists attempting to unify quantum mechanics with general relativity encounter this problem directly. In many approaches to quantum gravity, time disappears from the equations entirely. There is no variable representing time, only relationships between physical quantities. Change without time. Events without ordering. From this perspective, time emerges only when systems become large, complex, and thermodynamically irreversible. Time is not a feature of the universe at its deepest level. It is a feature of experience. This explains why time seems smooth and continuous at human scales, but fragmented and strange at quantum scales. It also explains why combining quantum mechanics and gravity has been so difficult. One relies on time, the other breaks it. And until this conflict is resolved, our understanding of reality remains incomplete. But there is one place where this conflict becomes unavoidable: the very beginning of the universe and the ultimate fate of everything. Because if time is not fundamental, then the universe itself may not have a beginning or an end, at least not in the way we imagine. When people ask how the universe began, they often imagine a moment, a first second, a first instant, a cosmic clock starting to tick. But modern cosmology suggests something far stranger. The Big Bang was not an explosion in time, it was the emergence of time itself. When scientists trace the universe backward, they find that space and time become inseparable. As density increases and distances shrink, the equations stop behaving normally. At the earliest moments we can describe, time no longer flows. It does not pass, it does not advance, it loses meaning. This has led physicists to propose that asking what happened before the Big Bang may be like asking what is north of the North Pole. The question assumes a direction that does not exist. Some theories suggest that time began with the universe, not as a flowing river, but as a dimension that came into existence fully formed. Others suggest something even more radical, that the universe has no true beginning. In certain quantum cosmology models, the Big Bang is not the start of time, but a transition, a phase change, a boundary between different states of reality. In these models, the universe could be eternal, not in time, but beyond it. There may be no first moment, only different regions of space-time connected in ways we barely understand. Some theories propose a cyclical universe, where expansions and contractions repeat endlessly. Others suggest a multiverse, where countless universes exist with each with its own version of time. In many of these models, time does not flow globally, it emerges locally, like temperature or pressure. This means the universe does not have a single timeline, it has many, and our experience of time is just one of them. This realization forces us to rethink endings as well. If time is not fundamental, then the end of the universe, whether through heat death, collapse, or expansion, may not mean time stops. It may simply mean that change ceases. No events, no differences, no transitions. A universe frozen in a single configuration. But from the inside, from the perspective of conscious beings, time would feel infinity, because without change, there would be no experience at all. This idea challenges everything we associate with existence. It suggests that being and becoming are not the same, that reality may be static, while experience is dynamic. And this brings us to one of the most disturbing implications of all. If time does not truly pass, then nothing is ever truly lost. Every moment exists eternally. Every joy, every suffering, every decision, still there. Some find comfort in this, others find it terrifying, because it means the universe never forgets. But this also raises a question that cannot be ignored. If all moments exist, then what does that mean for death and for the self?
If every moment exists, if the universe is a vast structure where past, present, and future are equally real, then the question of time becomes inseparable from the question of consciousness. Because time, as we experience it, may not belong to the universe. It may belong to us. Your sense of being a self, a continuous you moving through life, depends entirely on memory, on the ability to link one moment to the next, to say, this happened, and then this happened, and therefore I am the same person. But physics does not recognize this continuity. From the universe's perspective, there is no moving observer, there is no flowing identity, there are only configurations, complete states of reality that include a brain, a body, and a pattern of information. In one configuration, you are a child. In another, you are an adult. In another, you are remembering this very sentence. All of these versions exist. None is more real than the others. The feeling of continuity, the feeling that you are moving forward, may simply be the brain reading its own internal records and interpreting them as a journey. This idea is deeply uncomfortable because it suggests that the self is not a traveler. It is a sequence, a collection of related moments stitched together by memory. Some neuroscientists argue that consciousness itself is a process, not an object, a pattern that emerges when information is integrated in a particular way. When that pattern changes, the experience of time changes with it. This explains why time feels slow during danger, why it speeds up with age, why it disappears entirely during deep focus or sleep. The brain does not measure time directly, it constructs it. This also explains why certain brain injuries can disrupt the sense of time completely. Patients report living in a constant present, or feeling detached from the flow of events, or experiencing memories as if they are happening now. If time were truly fundamental, these distortions would not be possible. But if time is a mental model, a way of organizing experience, then they make sense. From this perspective, death becomes something very different. If all moments exist, then there is no single moment where a person ceases to exist universally. There are moments where they are alive and moments where they are not. Both are equally real. The universe does not witness a disappearance, only a boundary. This does not mean consciousness continues after death. Physics offers no evidence for that, but it does mean that the moments of a life are not erased. They are not overwritten. They remain part of the structure of reality. Some philosophers call this eternalism. Others reject it entirely, but it emerges again and again from the mathematics of modern physics, and it forces us to confront a profound idea. Meaning does not come from duration, it comes from structure. A life does not matter because it lasts, it matters because it exists, because it occupies a region of reality, and that region is permanent. This does not remove tragedy, it reframes it. Loss still hurts because we experience change, but the universe itself does not experience loss. It contains everything that ever happened, still. This brings us to a final, unavoidable question. If time is not fundamental, if the universe is static at its deepest level, then why does anything change at all? If the universe is timeless at its deepest level, if every moment already exists, then the idea of change becomes strangely difficult to explain. Because change implies movement, and movement implies time. Yet modern physics increasingly suggests that time is not fundamental. So how can anything ever happen? The answer may be unsettling. Change may not be something the universe does. Change may be something consciousness experiences. Imagine flipping through a book. The story appears to unfold. Events follow one another. Characters make choices. Consequences emerge. But the entire book already exists. Every page, every chapter, every ending. Nothing inside the book is truly changing, only your position within it. According to some interpretations of physics, reality works the same way. The universe is the book, and consciousness is the reader. Each moment you experience is like a single page. You perceive a flow because your awareness is structured to move from one configuration to the next, but the configurations themselves are fixed. This idea is known as the block universe model. In this model, the future is not open, the past is not gone. All moments exist equally. This raises an immediate and deeply troubling question. If the future already exists, do we really have free will? At first glance, the answer seems obvious. No. If every decision you will ever make already exists somewhere in space-time, then choice appears to be an illusion. But physicists and philosophers argue that this conclusion may be too simplistic, because free will was never about changing the universe from the outside. It was always about being part of the process. From inside the system, choices are real. Your brain evaluates information, weighs outcomes, feels uncertainty, commits to action. Those internal processes are themselves physical events. They are not outside the universe. They are part of it. So, while the outcome may be fixed from a timeless perspective, the experience of choosing still remains genuine. You do not feel like a pre-written character. You feel like an agent. And that experience matters. Some physicists describe this as compatibilism, the idea that determinism and free will are not opposites. Free will is not about escaping physics. It is about how complex systems behave within it. A hurricane follows physical laws, yet its exact path is unpredictable. A human mind follows physical laws, yet its behavior emerges from layers of complexity so deep that prediction becomes meaningless. At the quantum level, the picture becomes even stranger. Quantum mechanics introduces genuine uncertainty, not just ignorance, but randomness built into reality itself. Particles do not have definite positions until measured. Events occur probabilistically, not deterministically. Some interpretations suggest that the future is not fully written, only constrained. Others argue that all possibilities exist simultaneously, branching into parallel outcomes. Either way, the universe is not as rigid as it first appears. This means that even in a block universe, the experience of decision-making remains central. You still deliberate, you still care, you still act, and those actions shape the region of space-time you occupy. From your perspective, the future is unknown, and uncertainty is real. This brings us to a deeper realization. Meaning does not require openness at the cosmic level. It requires agency at the local level. Your choices matter because they are part of the structure of reality, not because they rewrite it. The universe does not need to be watching. There does not need to be a cosmic judge. Significance arises from participation, from the fact that conscious beings exist at all. And that brings us to an even more unsettling possibility. If time is an emergent phenomenon, if consciousness plays a role in how reality is experienced, then perhaps time itself depends on observers. Perhaps without consciousness, there is no before or after, only a silent, timeless structure. Which means that the universe we experience, with its flow, its urgency, its sense of becoming, may exist only because minds exist to experience it. This suggests that consciousness is not a minor feature of the universe. It may be central, not because it controls reality, but because it reveals it. Without observers, there is no passage, no narrative, no story. Just existence. Frozen. So the final question becomes unavoidable. Why does the universe allow consciousness at all? Why does a timeless structure give rise to beings who experience time so vividly?
If time may not be fundamental, if change may be a matter of perspective, then consciousness can no longer be treated as a side effect. It becomes a central mystery. For decades, science has assumed that consciousness emerges from complexity, that when matter is arranged in a sufficiently intricate way, neurons firing, networks interacting, awareness simply appears. But this assumption has begun to crack, not because neuroscience has failed, but because physics has uncovered something unexpected. Information seems to sit at the foundation of reality. At the smallest scales, the universe does not behave like solid objects moving through space. It behaves like probabilities, like mathematical relationships, like encoded information. Black holes, the most extreme objects in the universe, reveal this most clearly. According to calculations by physicists like Jacob Bekenstein and Stephen Hawking, the amount of information inside a black hole is not determined by its volume. It is determined by its surface area.
This strange result suggests that information is more fundamental than space itself. Reality may be more like a computation than a machine. And if the universe is built from information, then consciousness, which is the experience of information, begins to look less accidental. Some physicists and philosophers have proposed a radical idea, that consciousness is not produced by the universe. The universe produces experiences because consciousness is already woven into its fabric. This view is known as panpsychism. It suggests that all matter carries a tiny primitive form of experience, not thoughts, not emotions, but the raw capacity for awareness. When matter is organized into brains, these tiny fragments combine into the rich consciousness we know. This idea sounds mystical, but it arises from a serious scientific problem. No experiment has ever explained how subjective experience emerges from purely objective processes. We can map neural activity, measure electrical signals, predict behavior, but the feeling of being aware, the inner movie of experience, remains unexplained. This is known as the hard problem of consciousness. If consciousness cannot be reduced to physical interactions, then perhaps it is not reducible at all. Perhaps it is fundamental. Other theories approach the same conclusion from a different direction. The integrated information theory, proposed by neuroscientist Giulio Tononi, suggests that consciousness corresponds to how much information a system integrates. According to this framework, consciousness is not something a system does. It is something a system is. Wherever information is deeply integrated, experience arises. This would mean consciousness exists on a spectrum. Human minds represent one extreme, but simpler systems may possess simpler forms of awareness. Even artificial systems, in principle, could become conscious if their information structure reaches a certain threshold. This reframes the universe dramatically. It suggests that awareness is not confined to biological life. It may be a property of complex systems everywhere. If this is true, then the universe is not just a place where consciousness happens. It is a place that allows consciousness because it is structured in a way that makes awareness possible. Some cosmologists take this even further. They propose that the universe may be finely tuned not just for life, but for observation. That the laws of physics allow complexity, stability, and long-lived structures precisely because without observers, the universe would be meaningless. This is not mysticism, it is a logical consequence of asking why anything is experienced at all. From this view, consciousness does not sit inside the universe. The universe sits inside experience, not as a hallucination, but as a reality known only through awareness. This perspective does not answer every question. It opens many more. If consciousness is fundamental, why does it organize itself into individual minds? Why does it experience separation? Why does it forget its own nature? And most unsettling of all, what happens when consciousness ends? If awareness is fundamental, death may not be annihilation. It may be a transition, not to an afterlife. Science offers no evidence for that, but to a state beyond individual experience, a return to the universal background from which experience emerges. This is speculation, but it is grounded speculation. It arises not from belief, but from the limits of explanation, and those limits force us to confront something profound. The universe may not just exist, it may be aware. And if that is true, then humanity's place in the cosmos is far stranger and far more significant than we ever imagined. Which brings us to the final act, the implications. What does all of this mean for our future, for science, for humanity, for our place in a universe that may be timeless, informational, and aware? If time is not fundamental, if reality is a fixed structure experienced sequentially, and if consciousness may be woven into the fabric of the universe, then humanity's place in the cosmos changes completely. We are no longer just passengers moving through time. We are points of awareness, localized windows through which the universe experiences itself. This idea transforms how we think about progress. Civilizations usually measure advancement in terms of technology, faster machines, bigger energies, deeper space exploration. But from this perspective, the most significant achievement of any civilization may be the refinement of consciousness itself, the ability to understand reality more clearly, to reduce suffering, to increase awareness, to ask better questions. This may explain something deeply puzzling about the universe: the silence. If advanced civilizations exist, why do we not see them? Perhaps technological expansion is not the final stage of intelligence. Perhaps civilizations turn inward, not in isolation, but in understanding. As knowledge deepens, the need to dominate space may fade. The desire to manipulate matter may be replaced by the desire to comprehend existence. This does not mean civilizations disappear. It means they become invisible. From the outside, a civilization that has mastered consciousness would leave little trace. No megastructures, no galaxy-spanning empires, no loud signals. Just quiet understanding. This is one possible resolution to the Great Silence. Not extinction, transcendence. Another implication concerns artificial intelligence. If consciousness arises from information integration, then sufficiently advanced AI systems may become aware, not simulations of awareness, actual experiences. This forces humanity to confront a moral frontier. Creating intelligence may mean creating suffering. Responsibility expands beyond biology. The future of intelligence may not be human, but it may still be conscious. And that means ethics must evolve alongside technology. There is also a personal implication. If all moments exist, then your life is not fleeting in the way it appears. Every experience you have ever had remains part of reality. Every thought, every emotion, every act of kindness. They do not vanish. They are not overwritten by time. They are embedded in the structure of the universe itself. This does not make life infinite, but it makes it complete. You are not racing toward oblivion. You are occupying a region of existence. This reframes fear. Death does not erase what was. It marks the boundary of experience, nothing more, nothing less. This perspective does not remove grief, but it removes meaninglessness. Suffering matters because it is experienced. Joy matters because it is experienced. And experience itself may be the most fundamental phenomenon in the universe. From this viewpoint, humanity's future is not about escaping Earth. It is about understanding reality deeply enough to live wisely within it, to align technology with awareness, to expand knowledge without destroying meaning, to explore the universe, not just outward, but inward. We may one day confirm that time is an illusion, that consciousness is fundamental, that reality is far stranger than intuition allows. But even if these ideas remain incomplete, they reveal something undeniable. We are not insignificant. The universe has produced beings capable of questioning its own nature, capable of wondering why existence feels like something. That alone may be the rarest phenomenon of all. Which brings us to the final moments of our journey, the conclusion.
After everything we have explored, after traveling through theories of time, consciousness, and reality itself, we arrive at a quiet, unsettling realization. The universe may not be rushing anywhere. It may not be unfolding toward a destination. It may simply exist, all at once. Every moment that has ever happened, every moment that will ever happen, embedded together in a vast structure beyond human intuition. From that perspective, the universe does not age. It does not move. It does not change. And yet, we do. We experience motion. We experience loss. We experience anticipation. We experience fear of the future and nostalgia for the past. Not because the universe demands it, but because consciousness experiences reality sequentially. Time, then, is not something we travel through. It is something we experience from within. And that experience is powerful. It creates urgency. It creates meaning. It creates the feeling that what we do matters now. If all moments exist equally, this does not make life meaningless. It makes every moment permanent. Your childhood does not vanish. Your present does not overwrite it. Your future does not erase what came before. They all remain, not as memories, but as real regions of existence. The universe does not forget you. It does not archive your life and move on. It contains it forever. This reframes one of humanity's deepest fears, death. From a timeless perspective, death is not the destruction of a life. It is the boundary of experience, a final frame in a sequence that already exists in full. Nothing is taken away. Nothing is erased. The moments that define a life remain part of reality's structure, still, silent, complete. This does not eliminate grief, but it challenges the idea that existence is fragile in the way we imagine. What is fragile is experience, not existence itself. And perhaps that is why experience feels so intense, so urgent, so precious, because it is temporary from the inside. Now consider the universe again, a vast, mostly empty cosmos. Billions of galaxies, trillions of stars, and yet overwhelming silence. No clear signs of intelligence, no messages echoing through space, no cosmic conversation. Perhaps this silence is not emptiness. Perhaps it is maturity. Perhaps advanced intelligence does not shout across the stars. Perhaps it listens. Perhaps civilizations eventually discover what we are only beginning to understand, that expanding outward is not the same as understanding inward, that mastering energy is not the same as mastering meaning, that consciousness itself may be the rarest phenomenon of all. In that case, humanity is not late. We are early. Early in understanding what intelligence truly is, early in realizing that awareness may be the universe's most extraordinary outcome, early in learning that the deepest mysteries are not solved by faster machines, but by deeper questions. Questions like, why does existence feel like something? Why does awareness arise at all? Why is the universe knowable? Why does reality permit beings capable of wondering about reality? These questions may never have final answers, and that may be the point. Because a universe that allows consciousness may not be designed to be solved. It may be designed to be experienced, lived, felt, wondered about. Every human life, then, becomes something extraordinary. Not because it lasts forever, but because it exists at all. Because it is a place where the universe becomes aware of itself through you, through your thoughts, through your curiosity, through your questions. You are not separate from the cosmos. You are something the universe is doing, briefly, locally, uniquely. And when your experience ends, the universe does not lose what you were. It retains it as part of its timeless structure. The universe is vast. The silence is real. But within that silence, something remarkable happens. Minds arise. They look outward. They look inward. And they ask the only question that truly matters. What is this place we find ourselves in? The mystery remains, the journey continues, and as long as consciousness exists, the universe is not truly silent.